Okay, this is a recap of stem leaf. More so the back-to-back variety. Okay, so essentially you need to remember that this is actually two stem and leaf plots. So let's just say that we had leaf A data here. So we did 6, 7, 8. So the way this works for leaf A, set A, whatever this is not data in context, but this is 62, 65, 69, 72, 75, 77, and 82, 82, and 89. So you're looking at each stem being the tens place and each leaf being the ones place. Actually, look at the key. That's not even true. This is 6.2, 6.5, 6.9. So you just have to be careful because I just realized that's like one thing that you might run into. So this is all the data. So a stem and leaf plot preserves data because you could list the data from the actual stem and leaf plot if you needed to. And we have to always make sure that we're looking at the key. Case in point, almost messed that one up. For my own self. So if we had set B, where we're looking at, okay, same stem, 6, 7, and 8. Let's get rid of this junk here real quick. Okay, so now we're going backwards. So this is 6.3, 6.7, 6.7, 7.8, 7.6, 7.5. Actually, we have to do it the other way. 7.5, 7.6, 7.8, because we're reading it like this. And then 8.1, 8.1, 8.2. Okay, so having these two stem and leaf plots separately don't really allow you to compare them whatsoever, but putting them back to back, so instead of having a stem and leaf just go off to one side, it goes off to both sides, you can easily compare this data and say, okay, you know, if one of the plots was different than the other one, you'd be able to tell. And then this just like solidifies the fact that we have 3 numbers in the 6s, 3 numbers in the 7s, and 3 numbers in the 8s. So this kind of like compares the data side by side and lets you know, okay, hey, these two data sets are pretty similar to each other. And then you can confirm that with the box and whisker plot. So what can you find from the stem and leaf? So if I said find the mean, then you just add up all the numbers and divide by how many there are. The median, you would put in the data in numerical order, find the middle value. You could find that. The mode is the most often occurring. So you don't want to say 2 is the mode, but you want to say that for stem plot A, then in this case it would be 8.2 is the mode. So be very careful about that. And then here, actually leaf B is bimodal. So there's 2 modes, 6.7 and 8.1. Okay. You could find the range. So you would say, okay, well, I'm going to look at the max value, which is 8.9. And then I'm going to subtract out the minimum value, which is 6.2. And then that would be the range, whatever you get for that. What is that? 2.7. Didn't even need to regroup. Okay, so make sure that you know that stem and leaf plots, how to read them. You're going to need to know how to read a back-to-back plot. You're going to need to know that the data is preserved, which means you can find the mean, median, mode, range. You're going to need to know to use the key to make sure that you know how to read the stem and leaf plot. So if you have questions about any of that or any of that needs to be clarified,